Hello all. In this session, we'll discuss about insertion of the node at the end of the linked list. If you see in this diagram, head points to the first node. The data is 21 and second node 31, third node 12. After that, we don't have any other nodes. As we knew, this one is data, this one is a reference or pointer or address. Let us say address of this node here 100. This is the address which is holding next node location. This 100 is a address where this particular node resides. In the same way, second node, this one, data is 31. This is a reference. Let us say this address or reference equal to 200. So the third node address or location is 200. Again, third node is having the data 12. It is not pointing to any other element. So that's the reason it doesn't have any pointer or reference. So it is pointing to nothing. Null we have here. In this particular case, try to insert the node, new node 42 at the end of the list. Okay. At the end of the list, that means after the node 12, node is having 12 data, we need to insert a new node 42. After insertion, the picture is like this. Head 21 as usual. After that 31th, then after that 12, after that 42. The last node is 42. It points to nothing. These are the steps. Create a new node and set it next pointer as null since it will be the last node. Store the head reference in a temp or any other variable. If the linked list is empty, make the new node at the new node add the head and return else traverse till the end of the list. The final one, change the next pointer of the last node to point to the new node. In the original linked list, what is the last node? 12. After that, new node is coming. After 12, 42. So again in this node, it doesn't have any reference because after this, no new node. Okay. Now we will try to see the code. Firstly, we'll create a node class. So if you understand this defines a new class called node. A class we all knew it is a blueprint for creating objects. In this case, each object represents a node in the linked list. This is the constructor method. It runs automatically when you create a new node object. Self refers to the current instance of the class. That means the object being created. Data is a parameter passed in when the node is created and it represents the value that the node holds. Okay. Stores the value data in the node. Then we have seen self dot next equal to none. It initializes the next pointer to none. In a singly linked list, each node points to the next node in the list. We have seen in the diagram. Okay. After 21, 31, after 31, 12, after 12, 42, like this. So each node points to the next node. Likewise, the last node points to nothing. If next is none, what does it mean? It means that the node doesn't point to any other node we discussed. Now, this line defines a class called singly linked list. Here we have a method init. This is the constructor of the class. Self head is the starting point, first node of the linked list. We have seen here. Initially, the list is empty, so head is set to none. Here, now we'll see the code snippet for insert at end. This particular method insert at end. This method adds a new node at the end of the linked list. Node creates a new node containing the value data, whatever the data we passed in. It is a new node to be added. If not self head, that means self head is none. That means if the list is empty, the self head becomes the first node, okay, in the list. Else, this is the code statement current equal to self head while we are traversing. In this while current dot next, we are traversing the list until it finds the last node. while current dot next, current is equal to current dot next. Here if you see, we need to traverse from here by using the head. So this is not a last node, right? Because it is pointing to another node. Again, second node, it is pointing to third node. Okay, we have seen the addresses like this, right? 100, 200. Okay, here also same thing. These are the addresses. So it traverses from one node to another till it finds the last node here. At the end, again, if you see, when it finds the last node, then at that time it perform current dot next equal to new node. In this case, 12 is the last node in the original list. After this, new node 42 needs to be added. So in the original list, 12th is the last node. When it finds in this particular node reference, the new node address needs to be stored. That's how it works. So for that reason, we have this particular instruction, current dot next equal to new node. Now we'll see display method. Again here also, if not self head print, that means self head is none. That means the linked list is empty and it has to return. And we need to take any variable or temp or current, we need to point to head for traversing purpose. While current print current dot data current equal to current dot next. So once it is completed, it has to traverse from beginning from here till end. At the end, we have the last node points to nothing, right? So it's none. Print none. This is the display code. Display the list items. This code for insertion of the node. So if you understand this one, display, this method prints. This method prints all the elements in the linked list from head to end. If the list is empty, this one, it prints a message and returns. That means the linked list is empty is a message. Otherwise, it starts from the head and loops through each node using current dot next. For each node, it prints the data, whatever the data present in the node. That means these are the data points. 21 is a data. Here 31 is a data. Here 12 is a data. Here is 42. So for each node, it prints the data followed by this particular symbol. When the loop ends, the last node is reached. It prints none. Now we'll create a linked list with user input instead of hard coded. Linked list equal to singly linked list. This creates an instance of the singly linked list. Now let us say n equal to input. We are taking the user input for the data. Enter the number of nodes. How many number of nodes you want? Nodes to create. We'll take for loop. Let us take one variable for I equal to. For I in range function, we'll use it here. Whatever the data we have entered here, that means n number of nodes we are taking, right? We'll convert this particular data number of nodes to int because this particular input function results the string output. So we need to convert it int. Okay. Here we need to take the data equal to again input function, enter the data for node I plus 1. That means take a number n from the user, correct, right? This is how many nodes you want. In a loop, it asks the user to input data for each node. It uses the insert at end method, this one, insert at end method to add each node to the end of the list. Now displaying linked list after creation. Print linked list after creation. Then we'll call the display function here underscore display. This means just we are calling the display method to show the current list. Now inserting a new node at the end. Till now what we have done, we have created a original linked list. That means this one. So once we create a linked list, anytime we wanted to add new node, like insert the new node 42 at the end of the list, so we need to take the new data equal to, we'll take input again, input function, input, enter data to insert at the end of the list. Okay. Now linked list, we'll have to call the function to add new data. So we are asking the user for one more piece of data, appends it to the end of the existing list using insert at end. this one. Now finally, after new data insertion, we need to print this print particularly to display the updated linked list items. So this particular list display to show the final state of the linked list after insertion new data. So this is the program for to insert the node at the end of the list. We'll see any issues, this syntax errors. Save, run. Enter the number of nodes to create 3. Enter the data for node 1, 21. Enter the data for node 2, 31. Enter the node for data for node 3, 12. So the linked list after creation, this one, 21, 31, 12, none. This one. Now enter the data in to insert at the end of the linked list, 42. So this is the updated linked list, 21, 31, 12, 42. At the end, none. So that's all for this session.